Hey guys, so welcome back. This chapter is all about carboxylic acids and then their derivatives. So, also, I really am bad at pronouncing that. So, let's just get in. So, a carboxylic acid is going to be, you're going to have both a carbonyl group and a hydroxyl group on the same carbon. Okay, so this is going to be different than our aldehydes, right? Because in aldehyde, we had a carbonyl group and a hydrogen on the same carbon. And this is also going to be different than our ketones because a ketone is a carbonyl and then a methyl group on the same carbon. So when it comes to naming these guys, you just end it with oic acid. So here we have one carbon. So this is going to be methanoic acid. And then here we have two. So again, you probably guess it would be ethanoic acid. And then if we had three, it would be propanoic acid. Okay. So it's the same prefixes at the start like we used before, but now we're just going to write oic acid at the end. And then a majority of the times, especially on MCAT tested exams, this would typically be your highest priority group. Meaning, if you ever, when you're looking at the name of a molecule, and then you ever see oic acid at the end of it, you should immediately know that, okay, that is a carboxylic acid group. Okay, so definitely know this. This is a very common functional group. So the carboxylic acid can be turned into many different things, and we're going to go through those reactions later in the book. But for right now, again, we're just focused on nomenclature. So next is an ester. So an ester is when you replace your OH group with an OR group, and we're going to say R is any alkyl group. So like CH3, CH3, CH2, and then so on and so on and so on. So yeah. So the main difference is you replace the hydrogen with a alkyl group. So when it comes to nomenclature, you always start with, this is a little different. So you start right here. You start what's at the end of your ester. So in this case, 1, 2, right? So that's where you get the ethyl. Yeah, oh, sorry, yeah, handwriting's bad. But that's where we get the ethyl, right? And then propa, right? It's going to come from here. Okay, 1, 2, 3. So it's going to be ethyl propanoates. Okay, and that's all you need to know about esters for now. So again, make sure that you can do that. Usually this part tricks people up, but again, make sure that you start with what's at the end and then you finish like you would finish. So our next derivative is what we call an amide. So an amide looks like this. So an amide is when you have a carbonyl group with a amino group. So when it comes to naming amide, the prefix luckily is just amide. So that's a pretty easy one. But there is some weird conventions when it comes to naming these. So let's say that you had something like this. So you can add different alkyl groups really onto your amide. So whenever you have an amide and you have like nitrogen bonded to something, you always put N in front of it. Okay, so here we know this is an ethyl group, right? So we're going to do N-ethyl. Okay, and then we know that's a methyl group, right? So we're going to do, again, N-methyl. Yeah, and I did ethyl methyl in order again because we're going to follow nomenclature rules, and that says that we do it in alphabetical order. Okay, so make sure that you understand that if you see N and then a alkyl group, that means that it's a nitrogen. Okay, and then the rest of this will be butamide. So again, but because 1, 2, 3, 4. So that gives you buttes, because butane. But again, like we said earlier, the end of an amide group, luckily, the suffix is just amide. So buta amide. Awesome. So that's pretty much all you need to know for amines. Yeah, again, and if, let's say that let's show you one example, actually. So, yeah, this example here, let's give you the example Kaplan gave you. So, when you have something with no carbons, this one will just be propanamide. Again, so prop because it's 3. So prop because it's 3, and then amide because that's just that group. It's just whenever, so you don't have to do like N hydrogen or something dumb like that. It's only whenever you have a methyl group or ethyl group, again, any one of those alkyl groups. So next and the last derivative is what we're going to call an anhydride. So anhydride is actually formed from 2 carboxyl reacting with each other. So this actually will form something that looks like this. And in acidic conditions. So now the way that we name these is this is another pretty easy one where the prefix is just going to be anhydride. But a lot like our ester, it's going to have a little different naming conventions that we're used to. So again, the prefix is just anhydride. And the way that we're going to name it is the front part and the back part are different. So what I mean by that is, let's say we had this. We're going to call this one ethyl. And again, ethyl comes first in the alphabet, and this is the ethyl group here. So that's going to be ethyl. Sorry, it's going to be ethanoic. Propanoic anhydride. So anhydrides, because they're made from these guys, it's still gonna be oic, because it's 2 carboxylic acid groups together. When you name your anhydride, because these were once former, those groups you still have, but instead of oic acid, you have oic anhydride. Sorry about that, slight oversight, but it makes a lot of sense, right? So these groups were once acids, right? But now they're no longer an acid. So it's still oic, but instead of oic acid, it's going to be oic anhydride. And again, you always just go in alphabetical order. So yeah, awesome. So next, we're finally done. Next, we're going to do isomers. So chapter 2.